The coordinate conversions that we're going to need to go back and forth from rectangular to polar coordinates include x equals r times the cosine of theta, and y equals r times the sine of theta. These should look familiar. So when we're talking about rectangular coordinates, we're talking about x, y, and when we're talking about polar coordinates, it's r theta. So if we need to find x, we take the r value times the cosine of theta, and if we need to find the y value, we take r times the sine of theta. And if I have the x and y values, and I need to find the r and theta values, r is equal to the square root of x squared plus y squared. And remember that the tangent of theta is equal to y over x. Just be very careful here that you are being mindful of the quadrant. Be mindful of the quadrant. Okay, so let's put these to use. This is to find x and y, and this is to find r and theta. So that might help you when you're looking back at your notes. These seem pretty easy, straightforward. Not easy, I hate to say easy, but they seem pretty straightforward as you go through these examples. But when you're putting it all together, be patient with yourself if you forget. Go back to your notes, utilize your notes, and if you're writing everything down, hopefully these notes will help you. Okay, we're going to convert 2 comma pi to rectangular coordinates. That means that 2 comma pi, those are polar coordinates. So when we have those polar coordinates, that means we have r theta. So we're given r and theta, where r is equal to 2 and theta is equal to pi. I'm actually going to plot this, just draw a rough sketch of it. Right? We only have to go out 2 circles. I go out 1 more than I really need to. A positive 2, and then I'm going to rotate it pi radians. And I am pretty sure I can almost tell what those rectangular coordinates are going to be, but I'm still going to do the math to make sure I get it. So I'm given r theta, and I want the x and y coordinates. So this is where I'm going to say x equals and y equals. X equals r times the cosine of theta, which is 2 times the cosine of pi. 2 times the cosine of pi is 2 times -1. The cosine of pi is -1, and 2 times -1 is -2. Y is r times the sine of theta. That's 2 times the sine of pi. And the sine of pi is 0. 2 times 0 is 0. So our x value is -2. Our y value is 0. So -2, 0 are the rectangular coordinates. And you can tell by looking at our sketch that that makes complete sense. We almost could do this problem, maybe not even almost, maybe we did do this problem without even doing the math, but that's going to be rare that we're going to be in that situation. So it's important for us to know how to use those coordinate conversions. Okay, I'm going to do one more example. Convert the square root of 3 pi over 6 to rectangular coordinates. So I'm going to identify that I have r equals the square root of 3, theta equals pi over 6, and I want to get x comma y. Therefore, x is equal to r times the cosine of theta, which is the square root of 3 times the cosine of pi over 6. And the cosine of pi over 6, if you need to write your ordered pair off to the side, I I encourage you to do that. The cosine of pi over 6 is square root of 3 over 2. So we'll have the square root of 3 times the square root of 3 over 2. This cosine became this square root of 3 over 2. And that gives us 3 over 2. And the y value is r times the sine of theta, which is the square root of 3 times the sine of pi over 6. And the sine of pi over 6 is 1/2. So here we have the sine of pi over 6, and that's equal to 1/2. And the square root of 3 times 1/2 is the square root of 3 over 2. So 3/2, comma, square root of 3 over 2. Let's get an idea of what this looks like. The square root of 3, comma, pi over 6 is going to be a point with a directed distance that's halfway between 1 and 2. Not a little bit more than halfway. It's about 1.7. And then we're going to have a rotation of pi over 6. So it's going to be on that pi over 6 line. So it's somewhere right about there. And that makes complete sense. I'm going to zoom in. That makes complete sense. Look at this. This is about 3/2, which is 1.5. And then going up, we've got the square root of 3 over 2. That's going to be about 1.7 divided by 2 is about 0.85-ish. So not quite 1. And you can see that that point, I almost did this pretty good. That point is about 0.8-ish, 0.9-ish, just below the first circle. And the first circle would have, right, that would be a 1. So that makes sense. Makes sense. Therefore, that's our answer. Those are our rectangular coordinates. Okay, here's one for you to try. -4 pi over 3. So you go ahead and try to convert those to rectangular coordinates. And when you're ready to reveal the answer, press play. So be sure to press pause. Okay, thanks for trying that on your own. If you got 2, 2 square root of 3, you got the right answer. So I'm going to draw a quick picture to show you. -4 would be 1, 2, 3. That's a very lopsided. Those are very lopsided circles. I can't even. There we go. Still not the best, but not as bad as it was. So 1 pi over 3, 2 pi over 3, 3 pi over 4 pi over 3. So somewhere right around there. So right around here. So right 2, and then up 2 times the square root of 3. Square root of 3 is about 1.7, so about 3.4-ish. And look at that. There's our points. It just about works. 2, and then this would be about 2 square root of 3. Now let me show you how I did that. X equals -4 times the cosine of 4 pi over 3. And the cosine of 4 pi over 3 is -1/2. So -4 times -1/2 is +2. And then y is -4 times the sine of 4 pi over 3, which is -4 times negative square root of 3 over 2, which is +2 times the square root of 3. And that's how we got our answer. So in the next video, we're going to go backwards. We're going to be given the rectangular coordinates and now have to find the polar coordinates. So those are the ones that are a little bit more challenging because we have to be mindful of the quadrant.